All right, this brings us to the last section of this unit, 6.7, and we're modeling with trigonometric functions. Well, what we're doing when we're modeling, remember, is we're using algebraic or mathematical expressions to model real-world occurrences. Now, real-world periodic behavior that repeats in a fixed time frame can be modeled with a sinusoidal function such as f of x equals, this should have an a in front of it. Crap, hold on. This should have an a right there. A times cosine b times parentheses x minus c, close parentheses plus d, or the same thing with a sine function. The period represents the time it takes to complete one cycle. Period is still exactly the same as it was in the last section, 2 pi divided by b. And the midline represents the average value of the function and the vertical shift. So the midline is going to tell you how far above the original, which was the original sine function, remember, has a midline of 0. So if you have a horizontal shift, or sorry, a vertical shift up, then that's going to tell you, the midline is going to tell you how far that vertical shift is. So the midline, wherever the midline is going to directly relate to you finding what d is, if you need to find the equation. Now, it's going to also be the average value of the function. So if you know you have a maximum value of 7 and a minimum value of 3 on your process, then all you do is you find the average of these. You're going to add these two together, get 10, you're going to divide that by 2, so the midline is going to be at 5. And if you look at that, that works out perfect. If 5, you're going to be 2 units away from 3, 2 units away from 7. So when you find the average, now notice that's different from finding the distance. The distance we were subtracting. Here you're adding these two, and the same thing would work if it's negative, because you're going to find what the midline's equation is. So you're going to find, in this case, x would equal 5, but if these were negative, then this would end up being negative 7 plus a negative 3, which would give you a negative 10, which gives you a midline of negative 5. So understand you're kind of doing the same thing, but not exactly. You're actually finding the equation of the midline. So if you had negative 7 and negative 3, your midline would be a negative 5, not a positive 5. Whereas when you take the top one and subtract the bottom one and then divide by 2, you're finding the amplitude. You're finding your amplitude A. So the average plus the amplitude is going to give you the max value. D plus the absolute value of A. Remember, A is going to tell you how far you're going to go up from your midline. And remember, D tells you where your midline is. And your average minus your amplitude is going to be the minimum value. So your D minus the absolute value of A is going to be your minimum value. Amplitude is how far we go up and how far we go down from the midline. Here's going up, here's going down. All right, so let's look at this problem. This is the type of problem that you will probably see on your modeling trig functions on the AP exam. They're going to give you an equation typically. You're not typically going to have to build something like this. I'm not saying that you won't have to, and there's not times that you will, but I think more than anything they're going to give you an equation and you're going to have to pick out the pieces of information from that. So Patty decides to ride the Ferris wheel at an amusement park. Her distance above the ground in feet after t minutes is given by y of t is equal to negative 20 cosine of pi t divided by 4 plus 23. All right, now let's explain why it makes sense for her distance while she's riding a Ferris wheel to be modeled by a sinusoidal function. Well, the simplest way would be this. The Ferris wheel is a circle, and the car Patty is in is on the outside of the circle, while the circle rotates around its center. This means that Patty is essentially taking on all values of theta as she completes a revolution. And that would tell enough. You know, we got the circle. Patty starts here and she's going to go up and she's going to come back down. So she's going to take on all those values of theta as she goes around. All right, estimate her height above the ground after 5.5 minutes. So remember, our equation here is her distance from the ground. So all we need to do is we need to find, we need to find her height from the ground at 5.5. So we're just taking 5.5 and plugging it in for t. Now, once again, when you go to calculate this in your calculator, make sure your calculator is in radians because our angles are in radians. So we've got negative 20 times the cosine of 5.5t. Nope, sorry, wrong. 5.5 pi, and I just wrote the 5.5 and put it in front of pi. You could do pi times 5.5 also and get the same exact answer, and then close parentheses plus 23. And you just want to plug that in your calculator, making sure that your calculator is in radians, and negative 20 cosine of, and it opens parentheses, 5.5 pi divided by 4, close parentheses, plus 23. All right, and the answer I get is 30.65 and some more decimals, but that's approximately how we could go ahead and go 654 to make it 4 decimals accurate. So she's approximately 30.654 feet above the ground. Now, answer the question. Estimate her height above the ground after 5.5 minutes, and just go ahead and write a sentence putting it all together. At t equals 5.5 minutes, Patty is approximately 30.654 feet above the ground. All right, so calculator question on that one. Calculator did all the work. If this was not a calculator problem, You could just plug it in and leave it like this, or if it's something that's easy, if it's not a calculator problem, it's probably going to be easily able to figure out what the cosine value is and then go from there. It'll be one of our unit circle values or something we can find from the unit circle, and you can go from there. This one with the decimal and the pi over 4 and all that, that's going to be a calculator problem. All right, what is the maximum height that Patty is ever off the ground? What is the minimum height that she is ever off the ground? And why is it not 0? All right, so quick, easy way to do this. We know that A is equal to, well, let's just say A first. A is equal to negative 20, but amplitude is equal to the absolute value of A, which is the absolute value of negative 20. So that means it's 20. Now, what is D? D is the vertical shift. Well, the vertical shift here is 23. And remember, we're talking about feet in all these. So the maximum, going from our little bit of notice, a little bit of notes there in the quick notes. Remember this, the D is the midline. So now that means that is when the thing is at the center. So then it's going to go, the amplitude is going to go this far above the midline, and it's go this far below the midline. So the maximum is going to be 23 plus 20. So it's going to be at 43 feet. The minimum is going to be the midline minus the amplitude. So that's going to be 3 feet. Now, why is this not 0? Well, the wheel should not touch the ground. And plus, where she's sitting, it has to be at a comfortable sitting position for loading. So you would want to have it at some point. You wouldn't want to have it at 5 feet, because then you're going to have a step ladder to get somebody in. You wouldn't want to have it at 1 feet, because that is really, really far down. Plus, she's going to drag her feet when she comes back in. You know, a lot of broken legs with 1 foot at the bottom. So that's why the wheel shouldn't touch the ground. And it should be at a comfortable loading height. Comfortable and safe. Loading height. All right, and part 4, what is the diameter of the Ferris wheel? Well, the diameter of the Ferris wheel, if we think about the circle, it's going to be the highest value, the maximum, minus the minimum value. So we have a maximum value of 43 minus 3, which is going to be 40 feet. Max height minus min. (43 minus 3) gives us 40 feet. Now remember, the diameter is what we're looking for, not looking for the radius. The radius would be the amplitude, and that would only be 20. So you could do maximum minus minimum, or once you found what the amplitude is, you could just do this as 2 times the amplitude. Either one of those ways would be perfectly okay to find that answer. All right, how long does it take the Ferris wheel to make one complete revolution? Okay, this is where we've got to kind of draw a relationship between this, well, cosine, and this. Sorry. One. X is 1. X is 0. X is 0. Sorry, the cosine is 1, X is 1. Cosine is 0, X is 0. Cosine is negative 1, cosine is negative 1, cosine is 0, cosine is 0, and then back up to cosine being positive 1, back around to here. So this period, notice, is also the same distance that we do with our radians to go all the way around a circle. 2 pi here, 2 pi all the way around. That's not a coincidence. That's exactly how it works out. So now what we need to know is we need to know with this situation, how does all this stuff here change the period? Because that's what we're talking about. We're talking about the period of this function. It needs to complete and get all the way back around to where it was. Now, if we talk about this graph, notice that it's going to be shifted up 23. It's going to, it's going to start here, and it's upside down, by the way, with the negative too. So it's going to start at the bottom, go all the way up to the top, and come all the way back down. So that's what we've got to worry about here. But all we've really got to find is how long it takes to get back to where it started from after it completes all of it. That's nothing more than the period. So the period, the new period, time to complete one cycle or one revolution, is nothing more than the old period, 2 pi, divided by whatever is multiplied by the variable inside. That's going to be pi over 4. Don't forget the 4. Remember, this is essentially taking the place of x, that t is. So we're looking for what's being multiplied by that t, and in this case it's pi over 4, so we're going to divide by pi over 4. Well, keep, change, flip. We got 2 pi, we can write that over 1, change and multiply by the reciprocal, 4 over pi. Pi's are going to cancel out, and 2 times 4 gives us 8. That means it's going to complete one cycle in 8 minutes. So it takes 8 minutes to complete one revolution. Easy breezy lemon squeezy. Just got to remember those formulas. Make sure you remember those formulas. They're very, very, very important when you're talking about trig functions. All right, that's all of that section.